Now we're going to show how to get started using Simkit in Netbeans. I'm using a Mac here, but everything should be very similar for PC. First thing is to create a new project. We can use the icon or File New. Let's create a new project. It's going to be a Java class library. We'll choose next. Let's call it OA3302W12. And as you can see, by default, it puts a folder into the Netbeans projects folder. Let's finish that. And it creates the source packages and the libraries. Now, as we can see, their only library is the basic JDK, so we need to add the Simkit library. So we right-click on the project, select Properties, and go to Libraries. If there aren't any libraries added, we want to add a library. And the Simkit library isn't there, so we want to create it. Let's click Create the Simkit library. Now we want to add some jars or folders. This assumes that you have already installed Simkit, and by default Simkit goes in the Applications folder, so we need to go all the way up to the Macintosh hard drive, into Applications, excuse me, and find Simkit. There's Simkit, and in Simkit there is a folder called lib. That's where the jar files are. We want to add both Actions and Simkit. We will be using Actions later. Then click on the Sources tab and add a jar or folder. It will bring you to the place you left off, but go up a level to Simkit, and Simkit src.zip file is where the source files are zipped. And finally, the Java doc add zipper folder, Simkit doc zip, and we OK that. We add the library, and now we're back to the properties of our project. We see that Simkit is a compile time library, and then when we go and check, we see that both the Actions jar and the Simkit jar have been added to the libraries path. The next thing we want to do is create our package. Now, one very important thing when you're programming Java is to always use a named package. The compiler will not force you to do this, but this is something which is really almost mandatory. I think it should require you to have a named package. Regardless, we can right-click and say New Java Package. And I want you to name this OA3302 and make sure that the OA are lowercase as opposed to the project name, which is uppercase. When naming a package in Java, it's best to use lowercase. And we click Finish, and we see that it appears here as a source package, and we right-click on that. The next thing we're going to do is create at least start our first Simkit module, and we create a new Java class. We're going to call it Arrival Process. And we will make sure that's in the package OA3302. We finish that, and it adds a bunch of stuff there. It automatically has the author Java doc tag. You can leave that. But we want our arrival process to extend sim entity base. So we type that in, and we see that it doesn't like that. It says it can't find the symbol. In general, Netbeans usually will put a little light bulb over here. So if we click on the light bulb, we can either create the class or add the import. We want to add the import for Simkit sim entity base. And we see that the red squiggly of death goes away. Now we'll save that. Now the next thing we do is we create a parameter. Remember, a parameter is a private instance variable with a setter and a getter. So we first Okay, we will define interarrival. Let's make that a little more camel-y case. So interarrival time generator is of type random variate. If you remember from the arrival process, this is going to be a sequence of interarrival times that could be, it could be random, it could be constant. A random variate is a very generic way to do that. So we see the red squiggly again, so we click on the light bulb and it wants another import, so we add that import. And we see that random variate is a, well, it's actually an interface from the Simkit random package. Next, we want to generate the setters and getters for this. Now, instead of typing it, which could run the risk of fat fingering, we're going to right-click, go to Refactor, Encapsulate Fields, and then we see that we have the getter and the setter both checked. The field's visibility is private, the accessor's visibility is public, and we refactor that, and you see that it has written the setter and getter for this variable. Next, we go to the state variable. The only state variable is the count of the number of arrival events. And remember, a state variable is protected. In this case, it's going to be an integer. We'll call it number arrivals. Now remember, a state variable has a getter but no setters, so we will right-click and refactor again. We will encapsulate the fields. We uncheck the set number arrivals, otherwise it will generate a setter. And then this is something Netbeans does. It's going to change the visibility to private unless we make it protected. So we refactor that, and we see that here is the get number of arrivals getter that we have. The next thing is to write our constructors. We will have two constructors. One will have no parameters, and we'll just leave that alone for the time being. That's the one we will not yet be using, but it's there for future use. Now, usually there will be two constructors, one, the empty one, as shown here, and the other one will have all the parameters as its signature. So in this case, we have the interarrival time generator as its parameter, and so we will put that in, and call the setter. Now it complains about, for some reason Netbeans complains about that. We will ignore that. Now, to write the rest of the class, we need to implement the two events. The two events are run and arrival. So run is a special event that is implemented through two methods. First is the state transition, which is done by the reset method. Reset. And the do-run method. Every other event only has the do method. So for arrival, we will have public void do arrival. Okay, so you notice that what I've done is I have, oh, and it has a little light bulb here. What does it want? It says add override. Why? Because reset is in the superclass, and so we want to, we don't always want to do this, but in this case, reset should always call the super, because there are sometimes things in the superclass that you want to make sure happen. Now the reset is where the state transition for run occurs, and remember the state transition for run is initializing the state variables. So we want the number of arrivals to be 0. Now the do run method has two parts. First is to fire the property change for all of the state variables. And you notice that I use the getter. So the standard way of firing a property change is to put the name of the property that is the state variable in a string as the first argument and use the getter to call the to get the value. Next, we schedule any events. So the run event schedules the first arrival event. We schedule using a call to wait delay, and we put in as the first argument the name of the event. We leave the do off. And the second argument is, in this form, is the delay. Now we can give a random variate as the delay. You may have noticed that I was able to do that very quickly. In Netbeans, when you type the first few letters and hit Control Space, it will finish it for you or give you a choice. Okay, so we are finished with the run event now. The arrival event, we do the same thing, except we do both the state transition and the property change in the same method. So first we will say number of arrivals, and I'll use a plus equal 1. You should use either a plus equal or a number of arrivals equals a number of arrivals plus 1. I discourage the use of the plus plus operator, but that won't hurt too much. And now let's fire the property change. Right. In general, every state transition has 2 steps. First, you change the state variable, then you fire the property change. You should always fire a property change whenever a state variable changes. And then finally, the arrival event is going to schedule itself. So we have a wait delay arrival, and enter arrival time generator again. And that is the class. We have what it needs are Java documentation comments. We have not done that here. Let us move forward and just test it out. So we are going to use a sub package. I'm going to call it run. So the idea is that we're going to put our components in this package, and we're going to put our main classes in this package. That's a nice separation. So we will now create a new Java main class. Let's call it run arrival process. And we see that it has been created in the OA3302.run package, which is where we wanted it. Right now, we need, in order to create an arrival process, we need a random variate. Now here's how you get random variates. You don't instantiate them, we use a factory to get them. So let's see how that goes. Okay, so let's define our variable. And we see here in this class, it doesn't know about random variates, so we need to add the import for it. And our enter arrival time, here's how we get it. There's something called random variate factory. And it's going to be a static call called get instance. You see there are a number of different get instances. The one we really want is this one, with the first argument is a string, and we can give it the name, case sensitive, of the distribution that we want, in this case exponential with a capital E, and let's give it a mean of 1.7. There are 2 ways of parameterizing the exponential distribution. One is by rate and one is by the mean. Simulation likes to use the mean. Other areas like queuing tends to go with the rate. So, but 1.7 means there's a mean of 1.7. Now we're ready for the arrival process. So, and let's just create this on one line, new arrival process. And we want to give it the inter-arrival time as its signature. And we see that it's red squiggling us, so we click the little, and we add the import. So now you may wonder why didn't it see that, and that's because imports are on a package by package basis. They don't go into sub-packages. So even though we're in a sub-package of OA3302, it could not see arrival process without the import because it simply wasn't visible. So there it is. Now the first thing that we want to do when we create a simulation component is just make sure that it gets the parameters that we are putting in. And we do that with a print line. And we're actually now ready to run it. And now it's not going to run the simulation, but it's at least going to check to see whether or not we have given it the correct parameter. And we see the inter-arrival time generator is exponential with a mean of 1.7. So that was done correctly. Now we are ready to rock and roll. So there's a class called schedule, which is Simkit's way of schedule is the class where the event list is implemented. And we're going to set it to verbose, true, meaning that it's going to, after each event, it's going to show you what event occurred and what the event list looks like. The other thing we need to do is we need to stop it, otherwise it's going to go on forever. Let's stop it after 10 time units. In Simkit, the time units are whatever you want them to be. So they're not seconds or years or days or anything. It's if you want to make them years, then make them years. So now the two calls to get things started are schedule reset and schedule start simulation. Reset is like a giant reset button. It finds all of the reset methods and invokes them, and then start simulation gets things going. So what I hope to see here is 10 time units worth of the simulation. So let's see what goes on here. And we've got something. So here's the run. Here we got the arrival process. Here we're starting the simulation. And you see there are two events on there. One is the run event that was put there by the arrival process. And the other is the stop event. That was when we said stop at time 10, it put a stop event on at time 10. And then it simply executes the event list algorithm. So takes the first event off and executes that at time 0. The run event occurs. It scheduled the first arrival. Then the next one was arrival. And that scheduled the next arrival, and so on and so forth, until here, where after the fourth arrival, the fifth arrival was scheduled after the stop time, and so the stop event occurred first, and when the stop event occurs, then the program ends. Now, just to make sure that the state transitions are working properly, there's one additional little resource we have. It's called a simple property dumper. Okay, and we see that it's been imported. We see that it is, in fact, in the package called simkit.util. And what it does is this is simply going to reflect all of the property changes. And the way we do that is by adding it as a property change listener to the arrival process. So we can say arrival process, add property change listener, simple property dumper. Now let's see what that does. When we run it, Now we see that every time there was a state transition, that the number of arrivals went to its new value. So when run occurred, it was initialized to 0. When arrival occurred, it went from 0 to 1 to 2 to 3 to 4. In general, this will show the state transitions. So this has demonstrated that the arrival process is working properly, and we are now ready to use it in our either by itself or in conjunction with another program. And now I need to stop.